These two concepts are extremely important. We have to distinguish between population and sample. If you don't understand these two terms, well, you'll be in big trouble. In year 12 methods and year 12 Spec, unit 3-4 Spec, unit 3-4 methods, they will talk about population and sample quite a lot, especially in Spec. Right? Let's say this. Look, a population refers to the entire set of the individuals that we are interested in studying. So it doesn't necessarily mean everything, right? While a sample is a subset of the population, please highlight or underline this sentence here. A sample is a subset of the population. The population includes all possible data points, whilst a sample represents a smaller, manageable proportion from which we make inferences about the population. All right. The key point here is a sample is always drawn from a population. That's the key concept here. Well, for example, if Yo-Yo goes to Boxhill Center and she randomly pick 100 individuals, okay? Now, I randomly select, let's say, 5 people from your group. So my data is called sample, and yours is called population. Okay?
Well, wouldn't like be 100 people in previous sample, like all boxes will be the population?
Oh, that's a good point. If I don't select people from her group, then yes, 100 people in her group is called sample, relatively to the entire population. So it depends on the context. Sometimes your data can be both population and sample.
So if like a sample is taken from the sample, then that's like also population.
Exactly. So look, let me continue my story. I randomly select 5 people from Yo-Yo's group, right? Now, Jing comes up. She randomly selects, let's say, 2 people from my group. Wow, surprise. 5 people in my group, they are now called population. Right, don't think, 5 is a small number. How can that be population? Because Jing selects people from my group. So now, Jing's group is called sample. My group is called population, relatively to her data. Right? So it depends on the context, depends on what 2 values you're comparing. Make sense? Okay. Here's another example. Mary High School has 1,000 high school students. Look, obviously in Australia, there are more than 1,000 high school students, right? But now we only study the students in Mary High School. In this case, this is population. Right? Make sense? Now, they have a combined height of 1,720 meters. Wow. What about the average height? What about the average height? Hold on.
That's 1,720 divided by 1,000.
Exactly. How do we usually calculate the average? Well, we add all values together, then divide it by total numbers, right? So that's 1.72 meters. Now, the principal of the Mary High School randomly selected 320 students. They have a combined height of 544 meters. Wow, we can calculate another average height. Attention, I'll calculate this average height.
The average height is
That's calculate. I mean,
just 320.
we use the total values divided by total numbers. Okay, so 544 divided by 320. That's exactly 1.7 meters. Well, two average values, average height. What's the difference between the two? Well, the first one is called population average or population mean. This is actually population, denoted as mu. I will use this notation here, mu. It's like a U, and you extend the average one here. And this is called sample mean, right? That is calculated from the sample data. Sample mean. Denoted as X bar. Look, I give notation now. Look, all the values calculated from the population data are called population parameter. The values calculated from population data are called population parameter. Population parameters. Okay? For example, the population mean. Also, you can find population variance, population standard deviation, population median, population mode, population proportion.
So what's the simplest stand for population mean?
For population mean, so that's mu. That's mu. It's U. And you have this multiple. It's not M, it's mu. It's called mu. It's a Greek letter. Okay? And this is X bar, X in the horizontal line. Like this. Yeah, right. This again, you can have like population mean, population variance, population standard deviation, and so on. Okay, etc. You have sample. All the values calculated from sample data are called sample statistics. They can use different phrases somehow. Okay. If your teacher asks you to collect some statistics, there must be some statistics. If your teacher asks you, grab some data with parameters, population parameters, we never say sample parameters, right? So be careful with this terminology. Right? Now here's a very important point here. Population parameters, they are all constant. Why is that? Well, obviously, these 1,000 students don't grow up in 1 hour. They have the same height. If I measure Kota's height after 1 hour, I measure it again. Of course, it's the same. He would grow up a lot in 1 hour or in even 1 day, right? They're all constants. They never change. However, sample statistics, they are all variables. All not constants, all variables. Why? Because the principal selected 320 students. Well, I can select another 320 students. And most likely, I will not select the exact 320 students as the principal did. Right? That's why sample differs from other samples. Because we tested different people's different individuals. Correct? Make sense?
感谢关注，我们下期课堂再见。记得点赞关注哦。